Hi, so now that we've covered most of the basic algebra topics, we're ready to start going into what's called solving linear equations. And in this video, we're just going to do the basics of doing that. Okay, and so just to refresh your memory, this term equation, it's a statement that two quantities or expressions are equal. Okay, and so remember what that means. That means that it has an equal sign. Okay, the problem has an equal sign. All right, and so whenever you first look at the problem, it has an equal sign in it. Okay, now we're going to get into this term. It'll kind of get hidden in the bushes as we go through the material because will be important in later classes. But there's this important type of equation called a linear equation. And right now we're just dealing with one variable. Okay, things are slightly different whenever we have more than one variable. But the idea of a linear equation is that whatever your variable is appears only to the first power. Okay, like that. All right, and so all right. Now, one thing that's going to be a little bit hidden is remember, whenever something's just to the first power, we don't write the exponent. Okay, and so i.e. there's no exponent on the variable. Okay, like that. So just to show you some examples, I could have 3x is equal to 15. Okay, so notice there that here's my variable. There's only one variable. This is an equation because the problem comes with an equal sign, and there's no exponent on this variable right here. Okay, so that's a really basic one. You might need to be able to even look to see what the solution of that equation is. Or I could have something that's pretty complicated that we'll see later, but I could have 2 times x plus 1 minus 3 is equal to 5x minus 2, like that. Okay, and so again, notice I have this really complicated looking expression, but here's my variable. There's only one variable, and there's no exponents on it. Okay, and so that's the idea. And also remember, I'm bad whenever I'm doing lectures to always use x, but remember, we don't have to have x as our variable, so I could just as easily have 5 times 2a minus 4 is equal to a over 6. Okay, like that. And then also make sure just to be careful whenever we say no exponents on the variable, there could be exponents in your equation. So I could have something like 5 squared times w minus 6 squared is equal to 10 to the third. Okay, there's lots of exponents in that equation, but here's my variable, and it's only to the first power. And let me just show you one nonlinear example. So whenever something's not linear, we say it's nonlinear. Okay, and so I could have something like x squared minus 2x is equal to 5, something like that. Okay, we do have there is only one variable here, and here it's only to the first power, but see here it's to the second power. We call that a quadratic equation. Don't worry about that term right now, but the key thing is to recognize it's not linear. One thing in the bigger picture, especially if you're going to take lots of math classes, is later on you're going to have to really be careful about whenever you are dealing with a linear equation or whenever an equation is nonlinear. We'll see that linear equations, once we practice it and get it down, there's kind of a procedure for how to solve even these complicated ones. That's pretty straightforward. But once you get into the nonlinear world, you got to be a little bit more careful and things don't work the same way. Now, what we're going to want to talk about is this idea of having a solution to an equation. We've already kind of talked about that in some previous videos, where we talked mostly about checking solutions. Okay, but and that's what actually makes something a solution. So a solution to an equation is a number that when I substitute in, so when I'll just abbreviate that subbed, but substituted into the equation produces a true statement. Okay, and so that's how. So that's the idea about what we mean by a solution. Now, what we're going to do is we're going to go through a process to get a candidate for a solution, and then we're going to plug that number in, and we'll say that we're checking. And so what we'll say is that that number checks into that equation or for that equation. All right, and so that's the idea about what we're going to be doing. But the formal definition is basically a solution is a number that checks. Now, I thought about mentioning this later, but I realized this is a good time before I start talking about actually solving. But the first basic principle with equations is that anytime you can, now this doesn't, especially at the beginning, this doesn't always happen, but we need to simplify each side. Okay, so we treat it like it's two separate problems at first. And remember what this idea of simplifying means is that you want to clear parentheses, okay, like that. If they're present, they're not always present, and then also collect any like terms. Okay, so this is something that we'll always do at the beginning before we actually start doing the solving. Okay, so just as a quick example with that, say I have an equation that looks like 3x plus 7x is equal to 8 plus 4, like that. All right, and so notice over on my left side, I have these like terms right here, 3x and 7x. So I'd want to collect those to be 10x equals, and then over here on my right side, those are like terms too. So we get 12, okay? Now, we won't cover how to solve this equation in this video, but we can at least talk about that simplifying part. So say I have 2 times x plus 1 minus 3 is equal to 4 times x plus 5, like that. So the first thing I would want to do whenever I start solving is first I want to distribute to get rid of these two sets of parentheses. And so I distribute the 2. I get 2x. Remember, be careful, distribute over both of those numbers. So I get 2x plus 2, and then I just have that minus 3 at the end. Now just keep your equals, and all we're doing is simplifying each side right now. We're not solving. So now I distribute that 4, and I have 4x plus 20. 4 times 5 is 20. Okay, and then notice right here I have these like terms, 2 minus 3. And so 2 minus 3 is minus 1. So I have 2x minus 1 is equal to 4x plus 20. Now, don't worry about trying to solve this right now. That we're going to work up to that. I'm just showing you how we simplify things at the beginning of a problem. Okay, so I'm going to assume that now that we have an equation that either has been simplified or it was given to us simplified, so we don't need to worry about that layer of it. Okay, so now we're ready to start talking about how to actually solve an equation. And there's just this basic principle here that whenever we say two things are equal, it means that things are balanced. I should have said things there. Okay, or if we want to think about it, it means that the sides are balanced. Okay, and so what you can do is you can picture an equation as like a seesaw. Okay, so let's look at this basic arithmetic equation right here. So 2 plus 7 is equal to 9. And we know that's true. That's a true statement there. Okay, but I just want to illustrate this idea here of balance. And so the idea is that we have this seesaw, and we can think about each side of that equation as being weight on the seesaw. Okay, and so over on the left I have this 2 plus 7, and over on the right I have this 9. Okay, but since they're balanced, or since they're equal to each other, they're balanced, and so that means that seesaw wouldn't move up or down. Okay, but what would happen if I went and added a 3 over here? Okay, well, what would happen then is that seesaw would flip down. There would be more weight over on the left side, right? So what would I need to do to restore that balance? If I added 3 units over on the left side, I would add 3 units over on the right side, and then it stays balanced. Okay? And so the basic principle I'm trying to get at is that if I perform an operation on one side, do I do the opposite? What did I do? If I wanted to keep things balanced here, I added 3 here, but I also had to add the same amount of weight over here. And so I do the same on the other. Okay, that's a very common mistake for people to make. Once they start solving, they'll add on one side but subtract on the other. And so you're really knocking that thing out of balance then, because you're really tilting that thing whenever you do opposite operations. Okay, and so, sorry about that. So we want to make sure and do the same thing on the other side of the equation. All right, and that's going to lead us for how we can solve equations. Okay, first of all, just some verbiage. So you'll see this instructions. It'll usually say solve the equation or solve an equation or something like that. All right. And what that, for us, in terms of getting there, what that means is isolating the variable. Okay. Now, what isolating the variable means is that last line in your work should either be the variable is equal to some number and it's just the variable, or sometimes they get reversed. The number is equal to the variable. Okay, so that's a little abstract. So we might have something like x is equal to 3. Okay, or in this other form, we would end up with 3 is equal to x. And it's just sometimes because of the mechanics for how we solve and how the equation came to us, sometimes that variable is over on the right side. So don't let that throw you. Okay, but the idea is that we want to isolate. All right, so things that aren't isolated is x plus 2 is equal to 5. Okay, like that, because why? The variable's not all by itself on one side. Okay, or what if I had x is equal to 3x? Okay, like that. Here my variable seems isolated, but I still have part of the variable over on this side as well. And so that wouldn't work out for us. Okay, and so the main one that people mistake once we get into later on is you'll end up with negative x is equal to some number like that. That equation is not isolated yet because you don't have the variable all by itself. There's that negative attached to it. And we're going to talk in this video about how to finish that last step there. But this is a really common error for students to make is they'll get to this point in a problem and they'll stop. So remember, to have a solution, you need to isolate the variable, and what that means is that variable needs to be all by itself. Now you might be asking why. Remember, the idea is to find what the variable is, what number the variable is. Let's translate this back in words. Okay, x is 3. See, you're affirmatively saying what the value of that variable is. Whereas you look back at this one, you're saying negative x is 5. That's not telling me what the variable is. It's telling me what its opposite is, or its negative is. Okay, so now we're ready to get started. Now, one thing too, we're going to start pretty basic. So if you look at this example that I just put up, some of you can look at that and tell what the solution is. I would highly advise you to go through the mechanics now. And what I would do is, if you see what the solution is, that's great. But then go through the mechanics and make sure you can do the same thing by hand, because we're going to get a lot more complicated. So you want these basic things down before you start trying to do more complicated things, because then you'll be trying to learn too much at once. Okay, now the idea here is, in terms of the picture, we have this x minus 3 on the left side, and then it's equal to 8. So this scale is balanced, or this seesaw is balanced, although I didn't draw it that great, did I? Okay, so it's supposed to look where it's not leaning, okay? But so those two things are balanced. And then the idea here is that I want to isolate x. So I want to get x all by itself, all right? And so the idea here, let me rewrite it since I didn't leave myself much room, okay? So what I want to do is I want to think about what I could do on the left side so that I would just have an x left. Well, the problem is I have that minus 3 attached to it, okay? And so what could I do? To get rid of that minus 3, I could add 3 over on this left side, okay? Do y'all see that? Negative 3 plus 3 is 0, so this will go away now, okay? But what just happened? I added 3 over on the left side, okay? So right now, my seesaw just got tipped to the left. So what do I need to do to get it rebalanced? I also need to add 3 over on the right side, okay? Like that. And so I get x plus 0. I'll write it for our first example. So we get x plus 0 is equal to 11. But remember, 0 plus anything is itself. And so I just end up with x is equal to 11. Okay, like that. Now, one other thing, too, I'm going to advise you to do early on, even when you can kind of look and see what's supposed to happen, is try to get in that habit early of checking your answers. Okay, so we've been through that before. Here's my equation. X minus 3 is equal to 8, but I think x equals 11 solves this. Okay, so what do? I plug that 11 in. Okay, like that. Right now we're wondering if these are equal, but what is 11 minus 3? That is 8. And so that checks, and so then I know that this answer is correct. And that's whenever I circle my answers, once I know that it's correct. All right? And so try to get in that, there's a few things to get in the habits of early so that it's not haunting you later. One is even when the equation's pretty basic and you can see what the solution is, go ahead and go through those steps so you can just start getting that down as mechanics in your mind or in your brain. And then the other thing too is once you think you have a solution, go through and check it and make sure that it is correct. And the earlier you instill this habit in your math, it'll just become second nature after a while. All right. So now what just happened though? Let's look back at this problem. So we started with x minus 3 was equal to 8, and I needed to isolate the variable x. Okay. Well, the x wasn't isolated at the beginning because it had this minus 3. So what did I do on both sides? I did the opposite operation. Here I was subtracting, so I added on both sides. Okay? So that's a big general principle that'll help you decide what to do from step to step on problems, is to isolate the variable. Okay? You move numbers to other sides of the equation by performing the opposite operation. Okay. Like that. Okay. And I've left something out on both sides. Okay. You do the same operation, but I don't know if I'm explaining this very well, but whenever you're trying to isolate the variable and there's something attached to it that's keeping you from doing that, you look at what that operation is that's preventing it, and you do the opposite of it on both sides. Okay, so let's see if we can get that down here. And so here I have, say I have x plus 7 is equal to 4. Okay, like that. All right, and so again, I know this is basic, but well, this one might not be so obvious, but the key thing is here's my variable x, and then it has 7 added to it, and I'm supposed to get 4. So x isn't isolated right now. It has this plus 7, so what do I do to get rid of that plus 7? I do the opposite operation, so I subtract 7. Okay, like that. And so then I get x over on my left side, and I get 3 over on my right side, right? So now I think I'm correct, and so I want to go and check it. Okay, and so here's my equation. X plus 7 is equal to 4. All right, I plug in my x. 3 plus 7. Does that equal 4? Uh-oh, what is this? 10 equals 4? That's not true. Okay, I actually did that on purpose to point out something, all right? And this is what checking is all about. In this example up here, it verified that we were correct. But here I got an incorrect statement. All right, now whenever that happens, first of all, look back over your check and make sure you didn't make a calculation error, but 3 plus 7 is 10, so I know that's good, okay? So whenever you end up with a non-true statement and you're sure that your check is good, that tells you that you made a mistake back here, okay? And so we need to go back and see if we can find where that was, all right? And so let me get this erased. That was an incorrect check. Okay, like that. And so you have some options here. If you can't see where you went wrong, then just redo the problem, erase it all. But I can see where I made the problem. I kind of rigged this one, to be honest with you. It's right here. I had 4 minus 7. 4 minus 7 is negative 3. Okay, so I should have got negative 3 there. Okay, and so now look, whenever I go to check, I have my equation is x plus 7 is equal to 4. I'm plugging in negative 3 for x. With that, negative 3 plus 7, that is 4. And so that one does check. And so then I know I'm correct. So see, that's the idea of checking, is you'll get misled because I usually don't make mistakes when I'm doing these problems. Sometimes I do, though. But so you're going to see a lot of checks that go this way. All right, and so you're going to get used to seeing that, but make sure you realize I erased it. But you're going to, as you're learning, you're going to go through, and if you do your checks, you're going to end up at times where they don't end up equaling each other. So that tells you that you have a mistake you need to go back and find. All right, so here's 4 beginning examples here. So I would advise you to pause and see how you can do on these, see if you're starting to get it. And so I'm going to give you a chance to pause, but then I'm going to move on. Okay, so hopefully you pause and try these and we can go through them now. All right, so the idea is that we want to solve these equations, right? But one thing to do, and this has to do with number 4, hopefully you caught this. Remember, the very first step to solving an equation is to simplify each side. And so you should, before you get going, look to see if anything on either side simplifies, i.e., are there any like terms? And so B and 4 aren't like terms, so there's nothing there, and 27 is all by itself. So then we're ready to isolate. B is our variable here, and so I want to get B all by itself. What's the problem? It has a 4 subtracted from it. So then what do I do to get rid of that? I add 4 on both sides. Okay, so I add 4 on both sides. Remember to do the same thing on both sides too. And so on my left side I get B. Over on my right side, 27 plus 4 is 31. So I have B is equal to 31. I usually don't circle it until I've checked it. So I want to go and check it. Our equation is B minus 4 is equal to 27. And then I plug in my guess for B, or my candidate for a solution. We're wondering if those are equal, and then 31 minus 4, you could do that on your calculator if you don't know it, but that is 27. So it does check, and so I know B is equal to 31. One other note too, I should have mentioned earlier too, but make sure whenever you do your check, go back to the very first equation, the way it was given to you, because it's just so easy to make what we consider silly errors. And so, this problem only has one step, so it's pretty hard to see what I'm getting at. But if you check into an equation where you've done work, you may have made a mistake getting to that point. And so, long story short, always go back to your original equation to check from. Okay? Now, don't let number 2 throw you. It's just fractions, but we've reviewed fractions quite a bit, and so hopefully you're comfortable with them, getting more comfortable. The key thing is here, first of all, there's no like terms on the left, and there's no like terms on the right, so there's no simplifying to do. And so here's my variable x. The problem is it has this 2/3 added to it. So what do I do on both sides to get rid of it? I subtract 2/3. I do the opposite operation. Okay, like that. All right, and so here I have x is 4/5 minus 2/3. Okay, like that. And there's different ways you can handle it, but just remember we're subtracting fractions. You could keep going here and do all your subtraction, or you might keep going down. I just don't have any room. Or you could come over here on the side and do 4/5 minus 2/3. So remember how we subtract fractions. We need a common denominator, which is 15 in this case. Okay, like that. And then I'd need to multiply the first one on the top and bottom by 3. That gives me 12/15. The second one, I'd multiply top and bottom by 5. I get 10/15. So I have 12/15 minus 10/15. I have my common denominator, so I just subtract the numerators. 12 minus 10 is 2, so my solution is 2/15. Okay, and so that's what I think my solution is. Now, checking, you can check, okay, you can check this by hand. It gives you good review. So remember my equation is x plus 2/3 is equal to 4/5, right? So I'm plugging in 2/15 for x, okay, like that. And so on the left side, I'm adding I'm wondering if those two things are equal. On the left side, I'm adding those two fractions, so I need a common denominator again. That would be 15. So I multiply top and bottom by 5. I get 10/15. All right. And so now I add those numerators. Again, I'm still wondering if these things are equal. So I have 12/15 is equal to 4/5. What? Did I make a mistake? No. Remember, this reduces. What does this reduce by? This reduces by 3. So I divide 12 and 15 by 3, and I'm going to get 4/5. So that actually does check. Oops, sorry, that does check. So x does equal 2/15 in this case.
Now, I do think it's good to get practice by hand, but let me show you how to do this on your calculator because I don't want you getting bogged down with checking. I just want you to get in the habit of checking. So I'm going to show you how to do this on your calculator too. So if we come back over here, we see that this is what we're trying to check. Does 2/15 plus 2/3 equal 4/5? So to check this on your calculator, what you need to do is you need to type in the left side, hit enter, get its number, and then type in the right side and hit enter and get its number, and they should come out to be the same. Okay, and so notice here, if I typed in 2/15, okay, and then plus 2/3. Now the thing is, our calculator is not going to give us the fraction form of this answer. What it's going to do is it's going to give us the decimal. So see, notice that that's 0.8. All right, and now I go and calculate my right side, which is 4/5. And if my work is correct, I should get the same decimal. And I do, I get 0.8. So like I say, I just want you to get into the habit of checking, even if you're using your calculators for the ones that are more tedious. But please try to get in that habit.
Okay, so now moving on. Hopefully this one didn't throw you too much if you tried it. Okay, and so we have y minus 9 is equal to negative 9. Okay, and so just notice here's my variable right here, y. The problem is it's not isolated because it has this 9 subtracted from it. So what do I do to isolate it? I do the opposite operation. So here I'm subtracting 9, so I want to add 9 to both sides. Okay, that's that. All right, and then over on the left side, I just have y, and then on the right side, I have negative 9 plus 9. What is that? That's 0, okay? And don't let that throw you. 0 is a number, so it can be a solution. The key thing is, how do I know it's a solution? I go and I check it, all right? So anytime you get confused and if you're wondering if you did things correctly, check it, okay? And so I'm plugging in y equals 0. 0 minus 9, does that equal negative 9? Well, 0 minus 9 is negative 9. Okay, like that. And so that does check, and so that tells me that y equals 0 is the solution. Okay, so notice here, answers can be fractions. Okay, they can be whole numbers. They can be 0. They can come out negative even. Okay, and so don't let your answer don't let whatever your answer looks like throw you into confusion. Just check it and see if it's correct, and that's how you know whether or not you did things correctly. Okay, so let's look at problem 4. What's different about problem 4 is that it has some like terms on each side. Okay, so I don't want to start trying to isolate yet. First thing I want to do is clean things up, and so if you want to, you could move those like terms over by each other to make it a little bit simpler. Okay, this one only has like terms on its right side. Okay, 5x minus 4x is 1x, which we usually just write as x. Okay, so we get x plus 2 is equal to, and then 3 minus 5 is negative 2. Okay, now we're ready to isolate. There's no other like terms. And so here, my variable x, to get it by, right now it has this plus 2 attached to it. So how do I get it by itself? I do the opposite operation. Okay, so I would want to subtract 2 from both sides. Like that. And so here we don't get 0. You may have thought we were going to again. What do we get? We get negative 2 minus 2, which is negative 4. Okay, now this one's important for checking. See, even just moving these things into different positions, I may have accidentally miswrote it. I may have accidentally written that as plus. So we definitely don't want to check down here. We don't want to check this equation because I may have made a mistake. All right, and so if I wanted to check this, I always check in my original. So my original is 5x plus 2 minus 4x is equal to 3 minus 5. Now I plug x equal negative 4 into that. Okay, 5 times negative 4 plus 2 minus 4 times negative 2 is equal to 3 minus 5. Now this is the thing, especially if you're prone to arithmetic errors, feel free to check this on your calculator. So what you would do is you'd type in this entire left side just as it's written. Okay, so you'd want those parentheses. You just type 5 parenthesis negative 4 close the parenthesis. Remember to use the negative key and not the subtraction key. But you just plug in this entire left side, okay, like that. If you did that, well, I got to do this by hand. Negative 20 plus 2. Here I have negative 4 times negative 2. That's plus 8, like that. And then, so we're going to get negative 10, whether you do that by hand or plug that in on your calculator. All right? And then you compute the right side. So we're wondering if these things are equal right now. Then you compute the right side. I just paused because I realized these aren't going to come out equal. So we get negative 2 on the right side. All right, so those aren't equal. Something's wrong here. I was moving quickly with my check, so I need to make sure that is correct. Oh, I see where I see, and this is a case where I didn't check my check correctly. I was talking too fast. My solution that I think is correct is x equals negative 4. Remember what you do, you plug that in for x, okay? But what did I do right here? I plugged in negative 2 for x. All right, so my check is incorrect. So I didn't mean to do that one. And so that's a good lesson, though. Use those checks to help you, but sometimes it's your check that you're going too quick because we're trying to move on to the next problem and we rush the checks too much. Okay, and so let's try this again. 5 times negative 4 plus 2 minus 4 times negative 4 on my left is equal to 3 minus 5. And we're wondering if that's true. Okay, so again, you can use your calculator, so you just type in whatever you have over on the left side, or you could do it by hand. We have negative 20 plus 2 plus 16. That's negative 18 plus 16. That's negative 2 on my left. And then I go and compute my right side here. 3 minus 5 is negative 2. Those are equal to each other. Like I say, at least as far as it concerns me, I will have you do some basic checks by hand, but in general, especially once we get going, I don't mind if you use your calculator to check. I just want you to get in the habit of checking however you're going to do it. But one important thing about checking, too, you should do a check yourself. Checking is not asking someone if you did it correct. All right, there you're not learning a whole lot. And so try to actually do the check. I'm just saying either do it by hand or feel free to use your calculator. Now what we'll see is we can use the same principle even if things are being multiplied or divided, okay? So say I have something like 3x is equal to 15. And again, this one's basic enough where you might be able to see the solution, but think basic principles about how you can get it, okay? Remember what that left side means. It means 3 times x, right? And so I'm trying to isolate x, but it's being multiplied by 3. And remember what we do on both sides, we do the opposite operation. Now, you could say the opposite to multiplying is dividing. So you could say divided by 3 on both sides. We don't usually write that, though. Remember what I've been saying in a few videos is the fraction bar means divide. And so we could just as easily say over 3. Like that. Now in this one, I'll show you why we get x isolated. Typically, we just cross those out and we go straight to x on here. But the idea on the left side is, notice right here I have 3x over 3. Okay, if you think about how things reduce, those 3's cancel. 3 over 3 is equal to 1x. And so, but remember, whenever there's a 1 as our coefficient, we usually don't write it. So we get x equal. And then over on my right side, I have 15 divided by 3. That's equal to 5. Okay, like that. So I was just pointing out the reason why we get to, whenever we divide both sides by that coefficient, we just get to x. But usually we'll go straight from this line down here. Okay, now what do we need to make sure and do? We need to make sure and check it. Our equation is 3x equals 15. I plug 5 in for x. We're wondering if those are equal. What is 3 times 5, though? That is 15. And so that does check. And so now I have my answer. Okay? So yeah, if I haven't been explicit enough, addition and subtraction are opposite operations of each other, and multiplication and division are opposite operations of each other. Now, one other thing, too, because we'll be using that fraction bar for our divisions, notice that often this is an even division. 15 over 3 does equal 5, so we'd want to answer that way. Sometimes this won't be an equal division, so in that case your answer is a fraction, all right? And so if it doesn't reduce, that fraction will just be your answer. Let's do a quick example of that, okay? If it does reduce, though, then you reduce it, okay? So say I have 15x is equal to 10 instead, okay? And so I don't know why I wrote 21 there, so we have 15x is equal to 10 as our second example. Sorry about that. All right. So again, we're trying to isolate x, get it all by itself, but the problem is it's being multiplied here. So you perform the opposite operation on both sides. So I divide both sides by 15. Okay. And here they cancel, and so I just have x on the left. And then my answer comes out as 10 over 15. That's not an even division. Okay. So the answer is not a whole number, and that is a fraction. Then always, whenever your answer is a fraction, ask yourself, does it reduce? This does. It reduces by 5. So I divide each one of those by 5, and I get x is equal to 2/3. Okay? And try to get in the habit of checking. So I'm wondering, my equation is 15x is equal to 10. So I'm filling in that 2/3 and wondering if those two things are equal. Okay, you could use your calculator to do this, and so all you do is just type that in just as it's written. You do 15 parenthesis 2 divided by 3 and close that parenthesis, and then hit enter. All right, and the answer should come out to be 10, or you can get yourself some fraction practice. Here I'm multiplying two fractions, so I want to write that 15 over 1. With that, remember fractions we multiply straight across. Those don't look like they're equal, but remember, this means 30 divided by 3. 30 divided by 3 is 10. So that does check, and so we get that. All right, now let's look at this example right here. Okay, this one looks kind of tough, but we'll see if we think about that. If we always keep that basic principle in mind, it won't be that bad. And just remember, the other thing you got to remember in this is what we've been saying that fraction bar can mean. That means divide, right? And so here I have a divide, right? And I'm trying to isolate my x, but I have x divided by a number. So what's the opposite operation to division? The opposite to dividing is multiplying, okay? Like that. And so what do we need to do here? We need to multiply both sides by what? Multiply it by the number that's in your way. And so we want to multiply both sides by 12. Okay? And so here I have x over 12 is equal to 5. So I want to multiply by 12 and multiply by 12 on both sides. Okay? Like that. And again, if you think about this would be, in the bigger picture, once you get used to this, these will just cancel and you'll just have x. But to show you why, we're multiplying two fractions, so we multiply straight across 12x over 12, but 12 over 12 reduces to 1, and so I just get x. All right, and again, the way we usually do this is we just multiply both sides by 12 and realize those cancel, so we'll usually just jump straight down to here. All right, I was just showing the reason why we get that, but then over on the right we have 5 times 12, which is 60. Okay, so it looks like 60 is our solution. Why am I just saying it looks like? Because we could check. Hopefully you've seen from my lessons. It's easy to make mistakes. And so my equation is x over 12 is equal to 5. I think 60 is what x is. So now we're wondering if those two things are equal. But remember, 60 over 12 means 60 divided by 12. You may need to plug that in on your calculator to convince yourself, but that is equal to 5, so it does check. So my solution is x equals to 60. Okay, so why don't you try one here? Why don't you try, first let's use a different variable. I'm bad about always using x, but let's say a over 8 is equal to, let's do a basic one. I used 5 on the last one, so let's do a over 8 is equal to 6. Okay. All right, so hopefully you paused that and tried it. You still have time. But anyway, here's my variable a. I want to isolate it, but it's being divided by 8. Okay? And so What do I need to do? The opposite of dividing is multiplying, so I multiply both sides by 8. All right, and now that we understand why that works, we could just cross those two 8's out. And so over on the left, we just have a, so we have our variable isolated, and then 6 times 8 is 48. Okay, and again, just getting that habit of checking. Okay, and it'll become second nature, and so we think 48 is what a is. We're wondering that, but 48 divided by 8 is 6. Okay, and so a is 48. Now we know we've done things correctly. Let's do one more of these. And just remember, fractions are just numbers, so don't let it throw you. The idea is I want to isolate w. W is my variable in this problem. I want to isolate it. So the problem is it's being divided by 6. So what do? I multiply both sides by 6. Okay, here they cancel. And don't feel like you have to be able to see the answer here. Okay, w is 2/3 times 6, but then just take another step or two to actually figure out what that is. There I have two fractions I'm multiplying. Why am I saying they're fractions? Because I can write 6 as 6 over 1. All right, so I end up getting 12 over 3. 12 over 3 is 12 divided by 3, which is 4. So it looks like we're getting w is equal to 4. Okay, why do I say looks like? Because we need to make sure that we're correct. So we're saying w over 6 is equal to 2/3, and we think w is equal to 4. Now those don't look the same, but what's the idea here? 4 over 6 reduces, and so I would divide each one of those by 2, and then notice that I do get 2/3 is equal to 2/3. So w does equal 4. All right? And so that leads us to our next example. Say I have 3/5 x is equal to 4/9. Okay, this is actually a common type of equation form because of a big group of applications known as proportions. So we'll actually see equations that look like this. I'm not just trying to make things up. Okay, to bend your brain is what I was trying to say. So anyway, notice right here, what's my variable? It's x. Okay, but what's the problem? To isolate it, it's not isolated because I have this 3/5 attached to it. What is that 3/5 doing to x? It's being multiplied by x. All right, so to isolate x, I need to divide the opposite operation. So I divide both sides by 3/5. Okay, now just be careful, and you might, like I said, you can use the division sign, and it might help you because you got to remember what this bar is right here. We just divided. Okay, so we're doing 4/9 divided by 3/5. Okay, so now it's just back to arithmetic. How do you divide two fractions? You multiply by the reciprocal of the second one. That's the technical term. Or you can just say you flip the second one over and multiply. Okay, now we're multiplying fractions, and so we multiply straight across. 4 times 5 is 20. 9 times 3 is 27. Our answer is a fraction, and but see if it reduces. 20 over 27 doesn't reduce, though. So our answer is 20 over 27. That's that. And then we just go to check. Don't let it throw you. Okay, for my check, my equation is 3/5 times x is equal to 4/9. And we think that x is equal to 20 over 27. So I just filled in 20 over 27 for x. I went ahead and put that times sign in to remind me that that's not one big fraction, but two separate ones I need to multiply. Now we're wondering if those are equal. And see, notice over on my left side, I'm just doing a fraction multiplication. Now again, you could type this in on your calculator. I'm not saying not to, but sometimes it's just good to get, especially if you're rusty with fractions, good to give yourself practice. But anyway, I go and I multiply straight across. This is 60. 27 times 5 is 135, I believe. Yeah, like that. Now that one's hard to see if it's equal to 4/9. It's hard to see how it reduces, but it's pretty obvious both of these numbers here reduce by 5. Okay, so you could do 60 divided by 5 and 135 divided by 5. And so we get 12 over 27. Like that. And then and we're still wondering if that equals 4/9. And then both of these numbers reduce by 3, okay, like that. And so if I reduce both of those by 3, you get 4/9, okay. Again, I don't mind if you use calculators. Let me show you how that one would check with a calculator.
Okay, so yeah, to check this one with the calculator, here's what I'm checking right here, that 3/5 times 20/27 is equal to 4/9. So whenever you're checking with your calculator, don't try to type this whole thing in at once. Your calculator can't tell if things are equal, okay? I may not have pointed that out clear enough. You compute the left side, and then you compute the right side, and you see if you get the same number in decimal form. So here I have 3/5 times 20/27 on my left side. That. See, notice that my calculator's giving me 0.4444 on, right? All right, and then I go and compute my right side. My right side is just 4/9. Hit enter there, and see, notice that it's giving me the same decimal. So that's telling me that equation, my solution does check with the calculator.
All right, so now I know my answer is correct, and however you went about checking it, and so we can say x is 20/27 and circle it. All right, let's do one more example, and then I think we'll be good. So here I have this equation here. What's a little bit different about this equation right here is that over on my left side I have like terms, and over on my right side I have like terms. And so I want to collect like terms first, i.e. I want to simplify each side. And so here I have 8x minus 3x, that's 5x. And then over on my right side, I have 5 minus 30, which is negative 25. Okay, the reason I keep pointing that out and stressing it is notice whenever on the simplifying step, I'm not doing the same thing on both sides necessarily. Okay, here I am subtracting, but you may be adding things together here. You might not have anything to do over on this side. So on that simplify step, you're not doing the same thing on each side. But then once each side is simplified, to get the variable isolated, we always do the same thing on both sides. Okay, so how do I finish this now? I want to get x isolated, but it's being multiplied by 5. What's the opposite operation to multiplying? Dividing. Okay, like that. And so I have x is equal to negative 25/5. So now just remember how to divide sign numbers. I have a negative divided by a positive, so that's telling me that my answer is going to come out negative. And then I just do 25 divided by 5, which is 5. So my answer is probably negative 5. Why do I say probably? Because I still need to check it. Remember to always check back into your original equation. Don't check on anything that you've done work on because you may have made a mistake. All right, so I'm plugging in x equals negative 5. Okay, and we're wondering if that equals 5 minus 30. So first of all, I just compute the left side. 8 times negative 5 is negative 40. And then I have negative 3 times negative 5. That's positive 15. Like that. And then equals, and now I compute my right side. I have 5 minus 30 is negative 25. That. And so remember, we have negative 40 plus 15. So I subtract the numbers. That's 25. But I keep the sign of the larger one. So that comes out negative. So notice that does check. So x equals negative 5 is my solution. Okay, so I hope that's enough for you to go on and get you started. And then in the next instructional videos, we'll start solving kind of what we call full linear equations, more of the type that we'll see once we start doing applications.